Okay, everyone, so this is now going into Chapter 7, Lesson 9, which is on solving exponential and logarithmic equations. We're going to go ahead and get right into it. So we'll start with question number 1. So we're doing this one right here. I'll use this side to do the work. We have the equation 16 to the 3x power is equal to 8, and we need to solve it. Well, here's the thing. You cannot solve for a variable when it is in the exponent position. So what we need to bring that down. Somehow that exponent cannot be up there. Now there is a way, and I'll show you in a little bit how you can do it. Well, you know what? I'm going to do that first. I'm going to show you how to do it. This one way to do this is to basically rewrite it. Rewrite what is there. And you can't always use this strategy, but in this case, I see the number 16, I see the number 8. If it's possible to rewrite these base values with different bases, like in this case, I can write 16 with a base of 2, like 2 to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 to the 4th power is 16, and then 8 is 2 times 2 is 4, times 2 is 8. That would be 2 to the 3rd power. So if you can do this is one strategy. You write 16 as 2 to the 4th. Of course, the 3x is there, so you have to keep it there. And then this one, you write it as 2 to the 3rd power. Now you have equivalent bases, so you were saying that 2 to this power is the same thing, equal to 2 to this power. Well, if the bases are the same, and we have an equation which means both sides are equal, well then this exponent must be the same as this exponent, right? 2 to this exponent is equal to 2 to this exponent. Therefore, the exponents must be the same. So what you're doing is you're making a conclusion. This is using logic. Therefore, this little 3 dots means therefore. Okay, so when you see 3 dots like that in mathematics, that means therefore. Therefore, I can make a conclusion that 4 times 3x, the exponent, is equal to the other side, the other guy's exponent 3. And now we can just simply solve it. This is going to be a basic algebra equation now. 12x is equal to 3. You divide by 12, so it'll be 3/12, which of course is 1/4. So my answer here is x is 1/4. Write that down. Remember, you can pause, replay at any point, rewind as well. Okay, well, what I'm going to do now is I'm going to do the same question, and I should have just left it there, but I'm going to do the same question but using logarithms. Let me show you why. Now, so I'll rewrite it here. Again, I'm still doing question number 1, but I'm going to do it with a different strategy. 16 to the 3x power is equal to 8. All right, so what I'm going to do is I'm going to introduce a logarithm. See, once again, as I was saying earlier, you really can't solve an equation for x when it's up there. Even in the strategy that I use right now, I had to make a conclusion and say that 4 to the 3x, 4 times 3x was equal to something. I can't really solve it with x in the exponent position. So what you're going to do is do something that we learned last unit. You can introduce a logarithm because the properties of logarithm, when you introduce a logarithm, the exponent comes down as a product. So that's what I'm going to do. So I'll use red here. I'm going to introduce a logarithm on both sides because in an equation you can do whatever you want as long as you do it to both sides to balance it out. So if you want to introduce a logarithm, that's fine. Just make sure you do it to both sides. Once I do that, that's going to allow me to bring down the 3x as a product. That was one of the properties of logarithms. Remember, when you have an exponent, it can come down as a product. So it's like 3x times log 16. All right, at this point, now that x is on the bottom as a regular value, I can now try to solve for x, and all I have to do is divide because it's 3 times x, right? So I can get rid of the 3 by dividing by 3. But not only that, look, it's 3 times x times log 16. So if you want to leave x by itself, which is our goal, if you want to leave x by itself, just do the opposite of what the 3 is doing, what log 16 is doing, which is you're going to divide. So divide by 3 and divide by log 16, and that way that'll isolate the x. I'll go ahead and put it in red this time. So I'm going to divide by the 3 and by log 16 on both sides. All right, so this is what I do. And now that's going to leave me x by itself on the left side because the 3's will offset each other, the log 16's will offset each other. And on the right side, I have log 8 divided by 3 log 16. Now, this requires a calculator. All right, now let me go ahead and do that here. So I'm going to go control divide, since it is a fraction, control divide, and I'll put log, which is over here next to the 1. And then right here, let me see, I forget the numbers again. It is 8 on the top, 8. And on the denominator, we have log, so we'll go log, log, there it is. Remember, it's base 10, so it's a common logarithm. 3 and log 16. 3 and log 16. So I'll put log 16 there. And I need to put 3 in the front. Actually, it can go on the side. It doesn't matter. 3 times. So I'm dividing the log 8 by the 3 and also the log 16. So it's 3 times log 16. I don't know if I don't put the times, I don't know if it'll work or not. I know if I put it, it will work. All right, so there it is, 0.25, which of course 0.25 is a fraction. By the way, if you ever want to take a number and change it into a fraction, I believe you can go like this. Menu, number, and then approximate to fraction. And there you go. So it's menu and then number and then approximate to fraction. All right, 1/4. So you get the same answer as before, as I said earlier. So 1/4 is the answer to number 1. Okay, 1/4. All right, let's go ahead and do question number 2. Now, the only reason it took long is because this is the first time that we're using this strategy. It really doesn't take that long once you get the hang of this. So you do need to practice. Let me see, let's go. So in class, we will be doing that. All right, let's go to this one right here. Question number 2 now. So we'll do 15 to the 3x power is equal to 285. All right, here I'm looking at 15 and 285, and I might think to myself, ooh, this is the one where maybe I can rewrite these with the different bases, like 15 times something, or, well, 15 is just 15 to the first power. You can't say 5 to the some power is 15. It's not. It's 15. Now 285 is, let's see, 15 to the second power is 225. 15 to the third is already too big. So what I'm going to do is I'm going to introduce a logarithm here. So I'm going to go log here and log here. And that'll allow me to bring down the 3x in the front, just like before. So this one, you're forced to use logarithms here. Here we go. And now, remember, we're going to leave x by itself by dividing both sides by 3 and by log 15. So I'm going to go ahead and do that. I'll divide by 3 and log 15. Type that in, and that should get you your answer, whatever that is. So we'll go control divide. By the way, you can also use ln instead of log. Remember, you can use any logarithm if you want. And ln is actually easier because it's easier to not have, to avoid that 10 spot. So 285, so I'll use ln. But you can use ln or log. All right, so 285 divided by 3 log 15, 3 times ln 15. Remember, I'm going to use ln. So I'll use this, and it's 0.695. This one is not going to be able to, if you see this long set of numbers, you probably will not be able to change that to a regular fraction. You can try, but in this case, we're going to round it to 0.696, 0.696. So we'll say approximately, so we'll change this equal to approximately 0.696, and this is our answer to question number 2. All right, we're going to do question 3 next, the same way. Again, now that we get the hang of this, this is what we're going to be doing, all right? Let me see, let me just erase this one, get number 3 ready. So we'll do this one here. We're going to go 4 to the 2x power is equal to 6,000. All right, so once again, I can't solve for x up there, so I introduce log or ln. It really doesn't matter. Depending on the calculator you have, if you have one that just, if you put log and it doesn't require the little base, it might be okay to use that one. It's just that this calculator, when I use the logarithm, it has a little extra space for the box, which is kind of annoying. So I'll use ln. Okay, so I'm going to continue now. That introducing of ln allows me to bring down the exponent as part of the properties of logs right here. And here we go. I'm going to leave x by itself by dividing by 2 and by ln of 4. So it's 6,000 over 2 and ln 4. Type that in and you should get your answer. So it's 6,000 divided by 2 ln 4. So we'll do, let's get a new one here. Control divide, ln 6,000 divided by ln, what was it again? Sorry guys. You see, I'm trying to rush here, 2 ln 4. It said that my battery pack was running low for so I'm trying to rush here. All right, 3.138. So x is approximately 3.138. By the way, in your answers, I might leave the answers in this format, guys, on the assignment. So just be aware, if I do round them off, then you're going to go to the nearest thousandths. But if you don't, then just remember, I might leave it in terms of log or ln. I could have a log here or an ln. By the way, you'll get the same answer. The logarithm doesn't change the answer. Whether it's a log base 3, log base 10, log base e, like an ln in this case, it doesn't matter. You'll get the same answer. Just don't mix it up, though. It has to be the same base. Okay, so there's our answer for number 3. We're going to go ahead and do question number 4. This one's going to be a little different. If you notice, numbers 1, 2, and 3 all were exponential equations. In other words, it was an equation with the exponent as the variable. Now, number 4 has this is a logarithmic equation, where you already have a log. Well, there's a few ways to do this. So number 4 over here, again, I'm working on this one. It'll be log, and then it'll be 4x minus 3 equals to 2. Okay, you already have log, so you do not introduce log. But here's the thing. How do I solve for x if it's there inside that little expression there? Logarithm is there. I got to get rid of logarithm. So here's what you do. You technically are not going to get rid of logarithm. You're going to go back to the memory cycle here. Remember the phrase that pays, log b n equals e? That's going to come in to play. See, right now I have a base 10. It's not there, but it is there, right? It's an invisible 10 right here. So what you're going to do is you're going to rewrite this equation this way. You're going to say, all right, log b n equals e. The base is 10. So 10 is my base. 2 is the exponent. So again, log b n equals e. Log b n equals e. The base 10 goes to the second exponent and is equal to this numerical result. So the 10 to the second power is equal to 4x minus 3. All right, well, it's not going to be so bad. Now you can solve for x by adding 3 to both sides. You basically have 100 over here, 10 times 10, right? So now it's just a basic algebra equation. You're going to go ahead and add 3 to both sides. So plus 3, divide by 4 on both sides. And here is my answer. X equals to 103 divided by 4. You can leave your answer like that. Okay, number 5. And again, we'll talk more about these in class. So make sure you have good notes. And when you get to class, we'll have some more to practice. That's all you're going to need is practice. Once you get the hang of these, you'll see they're not that bad. All right, number 5. We're going to work on this guy right here. So we have, a couple of logarithms. Log x minus 3 plus log of x is equal to 1. All right, we're going to solve for x, and there's a couple of x's. There's also a couple of logs. Why don't we make this easier by simplifying and expressing this as a single logarithm? Now we got to remember, if the expression gets smaller, the operation gets bigger. So remember, the operation outside of the logarithm is a plus. So that's going to turn into a times. So you're going to write this as one single logarithm, and the first term is x minus 3. By the way, the x minus 3, you can't break it down anymore because there's nothing smaller than minus. So just take that x minus 3, and the operation that's outside is going to turn into a times, and then the x comes together. So remember, the expression gets smaller, the operation gets bigger. So the operation outside of the logarithm was the plus, which turned into a times. So it's the x minus 3 times the x from this one. All right, if I multiply that out over here on the right next to the log, that means I distribute this guy right here. It'll be x squared minus 3x. So it's the log of that is equal to 1. All right, at this point, I need to solve for x. Log b n equals e. Don't forget, there's an invisible 10 here. So the base is 10 that goes to the first power and is equal to the numerical result, x squared minus 3x. Okay, well, this is just 10. And if I go ahead and now, this is just a basic quadratic equation. So let's move the 10 to the other side. So it'll be 0 here. It'll be x squared minus 3x minus 10 equals to 0. And now we're going to solve this by factoring. So you factor this out. I'm going to go ahead and speed up the process. A positive times a negative equals a negative. Remember the FOIL method. And the bigger number is negative. So it's going to be minus 5 and plus 2. Let me clean this up a little bit. There you go. And now you solve for x. We've been doing a lot of these already. Remember, it's always the opposite here because x equals to negative 2, x equals to positive 5 because they got to go to the other side. So those are my answers, negative 2 and positive 5. Now, if you think about it, remember that with logarithms, you sometimes have to check the extraneous solutions. If I put a -2 back in this part, I already know you can't have a negative. Now you can